So, Vanakkam. So, we will continue our lecture on engineering seismology. So, we have been discussing about the past earthquake reported in the country. We also told that the country seismic zonation, okay, the 4 classes what we have seen, that 59% of the country actually in the seismic risk zones. Okay, so the seismic risk zone means which is likely to expected a high damage if earthquakes are occurring, which we have seen that very high risk zone of 5, okay, then the risk zone of 4, okay, high risk zone of 4, and then moderate risk zone of 3, and about 38 urban settlement are located on the these 3 regions, which need to be taken into account for the any city development and planning. We also look at that. So, there was many earthquakes of above 8 magnitude occurred before 1950, that is before independence. Okay, so those earthquakes are caused very extensive and severe damage. There is no any recorded earthquake data of those earthquake, okay, which is very unfortunate. So, because we don't have the seismic instrumentation, as we have been struggled during those period to survive ourselves itself. So, there is no seismic instrument, but at least we have the history of those earthquake and damage reports by collected by the several people. And then paleoseismology study. Paleoseismology study means, so people they go and dig a pit in that region and they excavate and see the cross section of the soil and comment about how the liquefaction is taking place, how the rupture is happened, if there is some evidence in the epicentral region. So, those kind of studies are even people are doing now. Okay, so there are many studies they do. So, they comment about the past earthquake magnitude and then the size of rupture and extensive damage apart from the available literature. So, those kind of study, paleoseismology study is also taken up. So, then we have seen that after 1950 there are many considerable earthquakes, particularly after 1985. Okay, so after 1985 there are many considerable earthquakes are occurred. Okay, so but these earthquakes, except 1 or 2, most of them are occurred not on the plate boundary. Okay, these are all occurred in the intraplate region as well as in the area which is close to the plate boundary, like a Delhi region. Okay, so those kind of occurs are occurred. So, let us see what are the major killing earthquake in India from 1200 to 2019. Okay, so this report I have updated recently, so that it will keep. So this you will not get straight away from any book, but it is compiled from the Wikipedia and then from the BILAM website and all those things. So, as I told you that the earthquake history is a well known for India. So, there was a record says that there was a earthquake in 1255, okay, 1255. Okay, so those period which is likely to be the Kathmandu Valley location where the earthquakes are occurred. So, about 1 lakh people died due to this earthquake, you can see. So, the lakh people on those days is a very big number. Okay. So, then the 1555 there was an earthquake in Srinagar, so where the 60,000 people died. Okay. So, then 9737, so Kolkata there is again 1 lakh people died. Okay. Then in 1819 Kutch region, so this was actually even the date was given because there was evidence record written literature. Other 3 earthquakes there is no such written literature. So, where they are told that about 1543 people have died. So, if you look at when we talk about the fault type, okay, we have talked about the normal fault, reverse fault. So, during that time I also discussed that there was a Allah Band, okay, so where there is a raise of the one side of the land, that was actually happened due to this Kutch earthquake, which is in between the Gujarat and Pakistan border. Okay, so that is the region. So, then 1885, okay, so 30th May Srinagar there was a intensity was reported, not the earthquake, it was written as a basically the intensity of 9, okay, where 3000 people died. Okay, similarly in 1897 Shillong, okay, 1500 people 9. This earthquake even has a well reported documents on this. Then 1905 Kangra earthquake 7.5, so about 20,000 people have died. Okay, so then the Bihar, okay, 1934 Bihar earthquake 8.4 magnitude, 10,700 people died. Okay, so 1950 Assam earthquake, so again 1000 people, 500 people died. So 1967 Koina earthquake, so the 6.7 magnitude, the intensity of 9 as cause. So you can see the intensity values, okay, the relatively the number of people die, you can see. See here 180 people died, here 3000 people died, but this magnitude are not known. Maybe somebody should study there and then find out this magnitude. I hope somebody might have done also, I am not very sure. Okay, so 1967 Koina earthquake, okay, so that is what we are discussing, where the 180 people died. So I also told, okay, so this earthquake actually the reservoir induced earthquake. Okay, so this was because of the storing of water in the dam. Okay, the source active near that area is triggered and caused a earthquake. Okay, so similarly the Uttarakasi earthquake, so again 6.6, okay, the intensity of 9, the number of people died is so much. Then Killari 1993, okay, so 30th September, the Killari there was a magnitude of 6.4, about 8,000 people died. Okay, so then the Bhuj, so these earthquakes we will discuss little. So while we will concentrate on these 3 years, you can see these earthquakes more or less it is similar. Okay, so similar in the sense basically if you look at, so the magnitude wise 6.7, 6.6 and 6.4, but if you look at a damage, okay, the number of people died, you can see basically the lowest magnitude of 6.4 where people have died many. Okay, so you can see 8,000 people have died. Okay, so the 6.6 1500, 6.7 180. So there is a the reverse. Okay, so basically the magnitude are increasing like that, but the death is increasing like this. That is what you can observe. So this because the time of earthquake, okay, the energy released by the earthquake. For example, 6.7 magnitude, okay, this was a reservoir triggered earthquake. Okay, so the time of earthquake and the location of the earthquake. So where the people living, okay, so where it occurring, so in the urban area or close to the urban area, far away from urban area, and occurring earthquake at the resting time. Resting time means people like evening like 5 to 6, from evening to the morning about 8 to 9. So those period if anywhere the earthquakes are occurring, you can expect a more human loss than a rest of the time. Why? Because these are all the period mostly all the kids will come back to home, family, mother will be there, father will be there. Most of them people complete their work, they will be in the home. So occurring of earthquake this time is actually very, very disastrous than the earthquake occurring at morning 10 o'clock or afternoon 2 o'clock, something like that. Okay. So those are all the factors which contributes here your number of fatality. Even though the intensity looks similar, you can see the intensities. So you can see the intensities are basically all of them are reported 9, but the number of people die. See 180 even you cannot even count as a log scale. Okay, so even 180 if you make it as a 10 time it will be 1800, then if you make another 10 time it will be, so 180 1800. Okay, so then the kind of other measurement is as a different follow pattern. So this kind of event very clearly indicates that, okay, so the damage not only the earthquake magnitude depend, it also the time when it occurs. Okay, it's a daytime, evening time, morning time, night time. So all those factors also contribute to that. Okay, so then we continue our discussion. So 2004, okay, so where the 26 December Sumatra earthquake, so 9.3 3 magnitude. Okay, so the intensity where 3 lakh people died in India. Okay, so this was very unfortunate. I told you that the tsunami warning. Okay, so we don't have the tsunami warning system. Okay, so because of that, even though the tsunami was actually reached after 2 hours of the earthquake origin time, we couldn't get any warning. So because of that, many people who are gone walking to the beach and people living close to the coast, all of them are died. So after this earthquake, Indian government taken initiative and installed many tsunami warning stations in the Indian Sea. Okay, so to prevent this kind of future lag. So 2001, 26 January, Bhuj, okay, India, there was a 7.7 magnitude, which about 20,000 people died. Okay, so this was also working day. Many school, okay, it was around morning time, I think, around prayer time or something there. So many school was actually damaged, a lot of people died, particularly this 26th, January 26th, okay, that's some of the festival day where we see that many school kids are okay, so assembled there, a lot of people have died due to that. So 2005 Kashmir earthquake, which is like also called as a Pakistan Kashmir earthquake, 7.8 magnitude, 80,000 people have died. Okay, so there are many people died in this earthquake due to improper evacuation of the people because of the disconnectivity of the between the place to place due to the many landslide and cutting of the road. Okay, the road got damaged, landslide occurred, so there is no connectivity between the different places. So that took long time to establish. By the time many people died due to hunger, even a people got a slight injury because they didn't get a proper medication and support, so they are all died. So that was one of the bad event where we made us to understand that the road networks are very important for the evacuation and the restoration. Okay, so the next, the Indian Myanmar Bangladesh earthquake on 2016. Okay, so where the 6.7 magnitude, 11 people have died, and then 1st March India Bangladesh again 5.7, so 3 magnitude. This was actually a Tripura earthquake. So there was a another earthquake on 2015, but there is no casualties like Nepal earthquake, which also affected the some part of the India, but not too much casualties reported in India. That earthquakes are not this one. So from here we can more or less clearly understood that if you want to even study a seismic hazard in India, you should will concern with that what happens in Nepal, what happens to Bangladesh, what happens to Myanmar, what happens in Pakistan. Okay, these are all the countries. Basically, geology of this country, okay, the tectonic of this country also will affect us. Okay, that is the message you can get from here. So if you look at the typical olden days photo shows a damage of this earthquake. This was the 1897 Shillong earthquake, so where it is taken from the encyclopedia Global Earthquake. You can see the photo. Okay, so you can see how it was disaster. You can see there was a I think the kind of a temple, okay, or the monk, the station where it has been completely destroyed. Okay, so this is again a Kankra earthquake. You can see here, because these are all even here, some of them are very traditional, this one. So this is actually 1934 Bihar Nepal earthquake. So you can see here. So these photos basically might be collected from the some of the British people who had that time kind of camera kind of things. I don't think any of the Indian might have taken this photo. So then this is a 2005 Kashmir earthquake. You can see so how the buildings are completely destroyed. So okay, so this one. So during this time I was actually studying my PhD, okay, degree program and a course on this earthquake engineering related course. Okay, so where you can see the lot of this one. So this is a 2004 tsunami to show you like how catastrophic the lot of damages, okay, is occurred. So you can see basically how the tsunami debris, okay, so it has been dismantled, and then all the waste what we thrown to sea has been thrown back to the land area. Okay, you can see the devastation occurred, okay, so due to this 2004 tsunami. So these are all the earthquakes, okay, which very clearly indicate that, okay, so all the seismic hazard, okay, are possible at a different part of India. So let us see some of the earthquake locations. Okay, what we have seen was actually the damage and here where it reported. So let us see the some of the earthquakes location in the map and try to understand where these earthquakes are more, where the earthquakes are less. Okay, so the figure shows the epicenter of large earthquake magnitude 7 or the intensity of 8 above, also greater earthquake of magnitude 8. One can discuss the accurate belt of large earthquake following in the Himalayan mountain, the belt and the Indo-Burma range. The maximum number of large earthquakes are however in the Indo-Burma ranges, or many of these are deep focus earthquakes. So less term casualties were less for this earthquake. You can see this earthquake. Actually you can see this was actually magnitude of 8. Okay, so then and 7 and 6. Okay, sorry, intensity of 8 and above has been reported. You can see very clearly there is a band of earthquake. You can see the narrow band of earthquake in the plate boundary. Okay, so these are all the shallow focus earthquakes. So this is basically a Indo-Burma Myanmar region where there is a deep focus earthquake and many events are there. Map showing the topography of the Indian subcontinent and epicenter of the great earthquake. So the great means earthquake magnitude of 8 and above. You can see this is the one earthquake, great. So this is another earthquake somewhere here. So then here, okay, this is a very old earthquake. So then this one, these are all the earthquakes. So the larger circle, okay, the 7 magnitude and above is shown in the larger circle. And the earthquake of 6 and above, where the intensity of 8 and above is caused as a small circle. You can see here, all those circles are the small circle. So you can see that there are many area there is no earthquakes of 6 are occurred. Okay, so these are all the area basically if you want to see very clearly. Okay, so we can map this area as a, so basically, okay, so then so these are all. So more or less if you connect all of them you can almost get similar to your seismic zone map, okay, where this is the higher zone. So these are all the area higher zone, okay, these are all the area very low zones are observed. So which very clearly indicate that this area, okay, so in the last 110 years, okay, so there is no bigger earthquakes are occurred or even they say that 1505. Okay, so there is no such a big earthquakes are occur. There may be possibility that this may be like big earthquake means 6 magnitude and above. So this kind of occurrence of earthquake one can expect, but that will cause many more damages, as we have seen that 6.4 magnitude 8,000 people died. Okay, so during the Killari earthquake. Those are all the evidence one has to be aware, to be account when you are doing the hazard analysis. Okay, that is the message. So due to the massive collision of Himalayas were formed and large number of earthquakes are generated due to this process, this plate boundary extend from Himalaya region to the Akran Yoma and a major cause of earthquake in this. So the Himalayan belt, because of the collision between the Indian plate and then the Eurasian plate and then the Burmese plate, all those things are basically causing several earthquakes in the border. Okay, so the Himalayan the Indian plate boundary border, okay, and also this side Indian Burmese plate boundary border. In addition to the earthquake occurring in the Indian Shield region, Indian Peninsula and adjoining part of the Arabian Sea and Bay of Bengal, okay, these earthquakes also significant. So majority of earthquake occur along the narrow zone of follow edge tectonic plate. That is what we have seen in this one, and these events known to be interplate or plate boundary earthquakes. Okay, so basically the earthquakes are occurring on these places. Okay, so these places you can see that. So we can see that there is a earthquakes are following a narrow band. Okay, so this narrow band due to the plate boundary action. Okay, so sometime earthquakes are occurs far away from the plate boundary. This arises due to the localized system of forces. Okay, the crust sometimes associated with the ancient geological structure such as a run Kutch. Seismic activity of the nature contributes to 1% of the annual seismic energy released by the globally. So the run Kutch is actually the interplate, but because of the formation of the plate tectonics, okay, the formation of the plate tectonic and the moment and the tensile force caused due to the moving of plate and rotation of the plate causes a many earthquake in the Ran Kutch, which is almost 1% of the annual seismic energy released globally. All the earthquakes in peninsular India falls under the intraplate category. Okay, so where this contributes to the seismicity of the. So the entire Indian can be divided as a three major seismic zones or the tectonics. Okay, one is that active tectonic shallow crust region, active tectonic shallow crust region. So the seismicity of Himalayan arc tectonic belt is associated with the under thrusting the Indian plate beneath the Eurasian plate. The tectonic active interplate regions are include Himalayan and southern Tibet plateau, northwest frontiers province of the Indian plateau. So these are all the regions are called as a active tectonic shallow crust region. The Indian plate what considered as a one of the fastest moving plate in the world. Okay, so before it colliding with the Eurasian plate, so it was moving very fast, collide with the Eurasian plate. Okay, so earlier it was moving with the speed of 20 centimeter per year. Okay, 20 centimeter per year. So the current movement of the plate estimated to be a 5 centimeter. Once it hit a Eurasian plate, the speed was reduced considerably, but still it is pushing. So what is the speed it is pushing? It is pushing around 5 centimeter per year. So we are losing our Indian land by 5 centimeter per year. Okay, so if the sea level continuously rises, okay, this losing of land where many of the sea region, okay, the region around the coastal, okay, area will losing the too much of land. Okay, the collision and subsequent formation of the Himalayan and Tibetan plate are associated with the high seismic activity. So because of this collision only you have the very high seismicity in this region. The entire northeast region is put under a zone 5, the Indian Seismic Zonation Code of BS 1893. This region falls junction of north-south trending Burmese arc and east-west trending a Himalayan arc. So these two arc basically responsible for due to this entire region has been suffered multiple phase of deformation process and is the resulted in the number of geological structures. Okay, so this was some of the geological study done by the Sharma and Malik. They have published this information. The another is the subduction zone. Subduction zones include Indus Pamir in the northwest frontier province, Indo-Myanmar arc, Andaman Sumatra seismic belt comes under this category. The northeastern India, especially the region China, Myanmar, considered the 6th most seismically active region in the world. So the northeast is the 6th most active region in the world. So the Indo-Burmese arc is important tectonic feature seismically which relate subduction of Indian plate underneath a Southeast Asian plate due to the northwest motion of the Indian plate. Okay. So the northeastern corner of India sandwiched between the Himalayan Burmese arc and it categorized by a complex seismotectonic setup and very high level of seismicity. The earthquakes in this area are inter-slab in nature. So these informations are needed because when you want to take a particular model to estimate a hazard, we should know that what type of model is suitable for a particular region. Okay, so for that this kind of classification and understanding of tectonics are very important. So Andaman Nicobar Island, which is situated southeastern side of Indian landmass, consists about 527 islands. The entire island chain is along the plate boundaries, India plate and Burmese plate. These regions comes under subduction zone. Okay, so this is basically a subduction zone which interface earthquakes. The region also put in the zone 5. The Indian seismic zone code, last damaging earthquake of tsunami in Andaman Nicobar Island in the past. The Sumatra earthquake December 26, 2004 occurred on this kind of region. So this places wherever seismicity happens are the subduction zone. Okay. So the another zone is actually the stable continent shield region. So the peninsular India delineated as a stable continent, okay, with low to moderate seismic activity. Okay, during the 1997 Chandra carried out, okay, the detailed study, and we classified so this region as the seismicity of this region intraplate in nature appears to be associated with the some local fault and weak zones. So the Rao and Murthy carried out study, and they commented about that most of the earthquake occurring in the southern part or peninsular India, okay, are due to the some local fault and weak zone due to the mass scale activity in the plates. So the east north east trending and west south trending Sun Narmada Tabadi zone, the predominant tectonic prevents the northern margin of the peninsular shield. The major tectonic elements of southern part of peninsula can be listed as a massive Deccan volcanic provinces, the southern Indian granitic terrain. Okay, these are all the some of the geological and tectonic, okay, the names in the south peninsular India different part. Dharwad Craton and Kadapa basin, Godavari and Mahanadi Garban, and eastern and western Ghats. Okay, so then the east and west coast respectively. So these are all the some of the tectonic major tectonic elements in the southern part of India. Okay. So the researcher, okay, like Purnachandra Rao, Gangadhara Rao, Arora and Reddy have highlighted that need for the seismic study of southern peninsular India because many of the earthquake sources are identified after the earthquake. For example, the Kilari earthquake, Koina earthquake, Jabalpur earthquake. After the earthquake only study has been carried out and found that faults are active. Okay, so if the carrying out a detailed seismicity study in the region will help to identify any such kind of sources are exist, as we have the poor seismic recording and we have seen that many part of the India, okay, so where there is no seismic record, okay, but because of the lack of seismic instrumentation and record, we classified those region as a low seismicity zone, a low risk zone in the code. The Bhuj earthquake 26 January 2001, casualty around 19,000 people. Lathar earthquake again 1993, so where around 8,000 people, okay, are the some of the deadliest earthquake in the stable continent region. There are about 10 earthquakes with magnitude 6 and above reported in the peninsular India. Okay, so these are all the major 3 active tectonic this one. So the peninsular India presents, okay, so quite picture except 1891 greater earthquake, some recent damaging earthquakes. So the same figure we are talking about the earthquakes on. So this in the nature because we are talking about the peninsular earthquakes. So there are number of moderate magnitude of 5 but less than 6 which caused considerable damage and loss of lives in the peninsular India, which was not marked in this map actually. But if you can study the seismicity, you can get all those information. So this gives a overall view of the how a earthquake data, a damaging earthquake or a killing earthquake reported in the India. Okay, that is what we could be able to understand. So now we have to at least glance through, if not all the earthquake, the major earthquake from different part of India to understand how these damages are caused. Because if you understand this only, you could be able to predict a damage or hazard due to the future earthquake. So for that purpose, we need to individually understand the each and every earthquake based on the recorded data available or the information available from the past, okay, in the form of literature or report, whatever, that will help you to give you a more insight view of these earthquakes. So with this, we close this class. Thank you very much for watching this video. So we will meet you again and continue our seismicity of India, okay, for a different big earthquakes caused. Thank you very much.